We demonstrated in this video is we've taken that example from the last video one step further. Now, instead of having a simple in-memory dictionary, we've now got an ASP.NET Web API running in AWS Lambda that's communicating with a SQL database within our network and storing the connection string and any other secrets in an encrypted AWS Secrets Manager. Hello everyone, and welcome to another video on modernizing your .NET applications to run using AWS serverless compute. In this video, we're going to continue on from where we left off in the last video, and we're going to have a look at a more complete real-world example of a .NET API. We've got an already modernized .NET Web API. If you're wondering how to do that, take a look at the last video where we take a .NET Framework API and modernize that to .NET 6. In this video, we've added some database connections to a SQL Server and also loading some configuration data from Secrets Manager. We've got this same values controller that we had in the last video that just stores key value pairs in an in-memory dictionary. What we've added on top of that is this product controller. We're using Entity Framework here to allow the listing and the creation of product objects. Relatively simple CRUD-based example, but it'll demonstrate some of the different ideas if you're doing things with databases and secret information like connection strings. Our product object is nice and simple. It just has an ID, which will be the primary key in our SQL database, a name, and a price. Nice and simple, as I said, but it will demonstrate some of the additional things to consider if you're using serverless with things like SQL Server and with connection strings. So typically, if you were building a .NET application, you're probably using the settings to actually manage your configuration data. So if I open up the settings file here, you can see we might have some kind of connection string specified in this file, and we might override that setting from environment to environment. Now, of course, it is possible to do that with Lambda. It would then mean packaging that settings file in with the bundle that you actually deploy to Lambda. And then where do you store that settings information? Do you store your connection strings in source control? And when we're using AWS, there is a better way to do this, and that is using AWS Secrets Manager. With Secrets Manager, we can store our encrypted secrets in AWS and retrieve them using API calls. We can then give the role that our Lambda function assumes permissions to be able to access that secret, and we might only give our Lambda functions permission to access that secret in production, so there's no possible way that anybody else could access connection string in the production environment. And then all our settings file has is this configuration option for the name of the secret. In this case, we're using a secret name of RDS DB secret. Now, if you're splitting your production environment and your dev environments into separate AWS accounts, you can use that same secret name in both places. If not, you might need to maybe prefix that with a dev dash or a prod dash based on the environment. We have that setting there, and then within our startup class, we can then retrieve that secret. If I just zoom a little bit, and we can see here we're creating a new credential provider, and we're going to try to use some credentials from my local machine, and this will allow me to either use a credential profile stored on my local machine, and if that doesn't exist, we will just use the role that the Lambda function has. So I'm going to try some AWS credentials from a profile called dev. That's what I use on my machine for my local development profile. And if that try get fails, I'm going to just create a brand new Secrets Manager client passing in no credentials. You'll see here that will then use the IAM role for my Lambda function. If my credentials do exist, if the development profile exists, I can then use a Secrets Manager client passing in my specific credentials. And this means I can run this API locally and still retrieve that same connection string from my Secrets Manager. I could be using Docker in this instance, and I could say, if I'm running locally, maybe use a localhost connection string instead of one actually in AWS. But in this case, I'm going to always connect to AWS. With my Secrets Manager client, I'm then going to retrieve my secret value. I'm going to use the get secret value API call of Secrets Manager. There's two things I'm going to do here. When I'm passing my secret ID, I'm either going to use a value from my environment variable as the secret, or I'm going to use the value specified in my settings file from my configuration. This allows me to potentially switch the connection string on the fly in Lambda using environment variables. Once I've retrieved my connection string from Secrets Manager, I'm then going to deserialize that into this database connection details object, and that will give me the various pieces of information I then need to actually build my connection string, of which I've got this as connection string method here to parse that. Part of my entity framework DB context, I'm then injecting my database connection details as part of the constructor of my data context, and I'm using that to, when I set up my SQL Server, to use the connection string from my database connection details. So when this API starts up, we're first going to retrieve the connection details from Secrets Manager, and we're going to store them as a singleton in our dependency injection container, and then we can set up our data context using them settings. To deploy the secret to Secrets Manager, I'm actually using the AWS CDK here to create both the networking resources and the database resources. Quick side note, if you're following along home and using this code, when you deploy the CDK resources, there are resources in there that will cost you money, namely a gateway and an RDS database instance. So just use this with care if you're deploying this in your own environment. One of the really cool things we can do with the CDK is actually we can automatically generate some database credentials. So you see I've got this method here to create my database secret, and it returns a database secret object. And all I need to say is I want to create a new database secret, give my secret a name. As you can see, this matches what we had in our configuration file. And then I can also say what username do I want to use. In this case, MS SQL user. And what will happen now is that the connection details will be automatically generated and stored in Secrets Manager. And they'll be stored as a JSON string that follows the same structure as this database connection details. So they create my database instance here, as they create my RDS SQL database. I actually pass in my credentials there, and I'm saying use the credentials from the secret I've just created. So that secret will be created, the secret will be stored in Secrets Manager, and then when RDS database get created, it will actually set it up using them same credentials. So that means that the same password, the same username, all of that information will be the same. So I've not stored any credentials anywhere at this point. I never need to store a credential. As part of my infrastructure deployment, them credentials are being created on my behalf. Nobody never needs to ever see these connection details. So when it actually comes to me deploying this infrastructure now, I can just use the CDK deploy command, passing in that profile that I use on my local machine. And after deployment, you see I've got a bunch of different configuration options that have been output here. As part of this CDK project, I'm creating all of the requisite network infrastructure, VPCs, security groups, subnets, and I'm also creating, at this point now, as output my various different details. Now, these are going to become really important when we come to deploy this API using AWS SAM. If I go back into Rider now, and I can open up my SAM template that I have here. And this has changed a little bit from the last template we looked at. I've got this set of parameters now, and this will allow me deployment time to override the network resources and the database secret to use. You can see as part of my API function, now remember we've only got a single function with an event of type proxy and a method of any, so that allows ASP.NET to handle the routing here, we've got this first additional VPC option. And this VPC config property allows us to configure the way that this Lambda function is attached to a VPC. Now, Lambda functions always run within their own Lambda service VPC, but we can specify a security group and a subnet that will then create an elastic network interface within our VPC or your VPC. That then creates that connection from your VPC to the Lambda service VPC. So the Lambda function will run within the Lambda service VPC, and the network traffic will be passed through to your VPC and routed from there. You can specify both the security group and 2 subnets to use from the outputs in our CDK deploy command. You see you've got the security group there and 2 subnets there. And the final parameter is the ARN of the actual secret that gets created. And we're going to use that in 2 places. The first is as an environment variable. Remember, in our startup code, we're saying pull the secret ID either from an environment variable or from the configuration file, setting that environment variable. And then we're also adding this AWS Secrets Manager get secret value policy, which will then give our IAM role that the Lambda function assumes permissions to be able to get the secret value from Secrets Manager. And that's where them parameters are going to be used. And at the point I run a SAM deploy and I pass in my guided flag, this wizard will now take me through with a few additional steps. Let's call this modernized web API. We're going to use US East 1 as the region. And you see I've now been asked for the parameter I want to use. The first being the security group ID. So if I can come back up there, grab that security ID, we'll paste down there, enter that. Been asked for the subnet. So I can go and grab the subnet, we'll copy that, and we will paste that there. Same again for the second subnet we want to use. Copy that, paste that down bottom here. And then finally, we've been asked for our secret ID, and we will use that CAR there. And then we go back to the wizard that we're familiar with using AWS SAM. So we don't want to confirm changes before deploy. We'll allow IAM roles. We won't disable rollback. We're okay that there's no authorization. And let's save all the details to a config file. This is now off and deploying. And one thing you will notice if you're using VPC attachment is that your first deployment will take slightly longer than normal. And that's because, of course, the Elastic Network interface has got to be created in your VPC. One thing to keep in mind when you're doing this is that that Elastic Network interface will use up one of the available IP addresses in the subnets that you define. And that will be one IP address per Lambda function. If you've got 100 concurrent execution environments, that's still only going to use one Elastic Network interface. But it's worth keeping in mind that you may end up exhausting the IP addresses in a subnet if you've got lots of Lambda functions alongside maybe lots of EC2 instances as well. Another thing to consider if you're doing this is how will your serverless resources work with your non-serverless resources? We're connecting to a SQL Server in RDS here. For each execution environment that Lambda creates, we'll get a separate connection to our SQL database. And as a default, we can have 1,000 concurrent execution environments in Lambda. That's going to be 1,000 potentially separate open connections to our SQL Server at the same time. Now, that might be okay depending on the load that you have through your application, but it might not. Now, AWS does have a service called the RDS proxy for SQL Server that shifts that connection pooling out of your application and into a proxy. And I have another video that I'll put in the link description below about how to use RDS proxy with SQL Server and your .NET applications to allow you to move connection pooling out of your application code and into the proxy. But the same does apply for maybe other APIs that you're communicating within your business. Can them APIs support the potential load that will come from moving to Lambda for your compute? That has finished deploying now, and we've got our API endpoint here. If I just grab a copy of that API endpoint and we flip over to Safari, put in a window there, and we can hit that API endpoint. Now, that cold start that you saw there obviously includes the retrieval of the secret from Secrets Manager. So one of the things you'll take on if you do this is that overhead of retrieving the secret from Secrets Manager and setting up the DB context. There's slightly more happening in dependency injection here, but you'll notice it still wasn't crazy amounts of time. Would estimate less than a second, but of course I don't have a stopwatch on. Now, one other endpoint I've added in this API, and I don't recommend you do this in production, but for the purposes of this demonstration, it makes things nice and easy, is I've added this DB update controller. This just allows us to execute our entity framework database migrations in a simple and easy way. I've just got a single get endpoint on /tools/db that will just apply the database migrations to my SQL database. So if I go back to my API endpoint now and I do /tools/db, that will then take a couple of seconds to set up the connection and it will migrate my database. That's now returned. So if I actually now switch over and hit my actual API/products endpoint, you see I've got an empty list of products, which is, of course, I've not actually created any products yet. If I open up Postman briefly and just come and grab the same API endpoint, we flip to Postman, I can then run a post request with my product name and price, hit that endpoint, and that will then return success. And if I go to my list endpoint now, I've got my list of products there. We demonstrated in this video, we've taken that example from the last video one step further. Now, instead of having a simple in-memory dictionary, we've now got ASP.NET Web API running in AWS Lambda that's communicating with a SQL database within our network and storing the connection string and any other secrets in an encrypted AWS Secrets Manager. That's all for this video. As always, if you've liked, then please subscribe and share. Feel free to reach out if you have any questions or comments, and I will see you next time.